So meanwhile, let me tell you about myself. So uh, my name is Abhijeet Kumar. Uh, I started my career with Infosys Limited. Uh, I moved from Infosys Limited to SunGuard AS. From SunGuard AS, I moved to Blue Yonder, Packet Enterprise, and I'm a backend engineer. Uh, yeah, primarily I'm a backend engineer, but I've been involved with DevOps for like more than 6 years now. Let me share my screen. So we'll go over some basic stuff first. Uh, yeah. So I don't know how many of you guys are familiar with what Docker is and why it is used. So we'll start with the very basic things. Like we'll first talk about is like what is the brief history around Docker, why we had to like bring in Docker, and like what problems does Docker solve for us. So initially
Sorry, Abhijit,
you can
we are not able to see your screen.
okay, I'm sharing my screen, but one second, let me. Is no one able to see my screen?
Yes, Abhijit, your screen is visible.
Okay, fine. Yeah. So yeah, let's talk about what used to happen before Docker was in picture. So before Docker was used, there would be a separate team. There would be a separate team for developers, and there like still it's a separate team. Yeah, but there would be a separate team of developers. There would be a separate team of testers, and developers would what they would do is they would write some code, and when they would write some code, they would somehow they would publish this code. And one of the tools that is used to publish the code right now we use is Git, but there are many different version control systems. So any of version control system can be used to publish the code. And then there would be a team of testers, and this team of testers would test the code. So what used to happen was when developer would write some code, uh, and the tester would test the code, tester might find something, tester might run into something that the developer did not code that way. Like a tester might find a behavior change in behavior. So why that can happen, or something can be missed. Like what the problem was that the developer would write some code and the behavior of the same code for developers would be different and for the testers would be different. Why would that happen? That would happen because a developer was using a dev VM or some dev environment, or maybe his laptop local system to write the code. And when he published the code, he published to some central version control, or maybe he would directly zip it and share it with the testing team. So anyways, the code reaches the testing team, and the testing team, they would run the code on a different environment, which can be QA, or uh, there is something called UAT, user acceptance testing, or something what else? Something like uh, staging, where customers they test out the product. So either of these environment, and these the code in these environments might run differently as compared to dev environment. So why that can happen? So a code basically, uh, in order to run the code needs several things. A code need access to OS resources. A code need access to the operating system. Uh, you know, uh, in order to execute, like let's say a code needs to make a network call, maybe a API call to some other um, third-party service. So in order to make a network call, or it might have to dump some log file, it might have to do some operation related to changing the configuration of the system. So these kind of changes, they require the code to interact with the operating system. So operating system has libraries that code has to trigger and use in order to do these things. So a dev environment might have this, uh, it might be a case that the OS or the version of the OS is different in dev and other environments. It might be a case that the dependent packages code also need, sometimes the code also have third party dependencies. So there might be a issue that the third party packages that the code uses, those packages might be different. So let's see what might be different in the environment. So dev environment, let's say version is one thing, then uh, dependencies, that can be one thing, and then um, what else, there can be some other things as well. uh, and these things have to be same in the QA. If these things does not remain the same in QA environment or UAT staging environment, any other environment, then the code uh, most probably will behave differently in the other environment. So this was basically a problem where the developers, when they created some code, that code would behave differently for the testers, and testers would often complain that the code is behaving differently for them. So this was one of the issues. Later, virtualization came along, and that allowed us to create virtual machines. So when the virtualization came along and allowed us to create virtual machines, the developers would then basically uh, write their code and publish their code in dev environment, and they used some particular um, image for their virtual machine. So they used one particular image for their virtual machine, and the tester could then use the same image of same virtual machine image and run the same code on that in their environment. So now the code would behave mostly same, because the same image virtual machine is running in both the environments, and the code is supposed to work the same way in both the environments, given that the dependencies are same in both the virtual machines. So if the dependencies are same in both the virtual machines, if the interpreter version, like let's say it's a Python code, then the Python interpreter version that has to be the same in both the virtual machines. So basically all the dependencies and all the uh, you know all the dependencies and all the third party packages, they must be of the same version. In that case, if we have a virtual machine, then we can achieve this consistent behavior. The problem with virtual machines is that the virtual machine use a lot of uh, resources when compared to Docker. So we'll get to that later. But like fixing one problem creates a different problem for us. Like creating a virtual machine is very inefficient resource wise. We'll have to create a lot of virtual machines, and then these virtual machines basically will run some software which might not be used a lot. So in that case, virtual machine will uh, not be properly or efficiently using the hardware resources allocated to it. And then there is another team that I did not mention here. There is operations team. uh, I don't have space left. So let me try to push it inside. So operations team is responsible for running, or basically operations team, what is the work of operations team is to um, uh, make the code or the software available to the customer, and run it and monitor it for any alert or any mishappenings. So that is primarily the work of the operation team. And the operation team also uh, runs into the same issues. Like if they are not using VMs, then in that case operation team can be using can be running the code on production environment, or maybe pre-prod environment, something like that. So it's same, it's a different environment version, operating system or the operating system version can be different, dependencies can be different, so the behavior of the code can also be different. And also if they use the virtual machine with same image, it might be possible that the version and everything remains the same and code behavior does not change, uh, and it brings in the same drawbacks, which is inefficient resource utilization. So these are the precursors to Docker. Uh, when we had this virtual image in, sorry, when we had this virtual machines in picture, we had almost solved the problem, but Docker solves the problem in a more better way. We'll see that later how it solves it in a more better way, uh, which has made Docker, or which has made containerization a technology like it is currently. Like it's a big technology, everyone uses it. So everyone uses it because it fixes all the drawbacks with the previous approaches. So we'll go ahead and like now we since this uh, Docker is like a technology mostly used by DevOps, we need to understand what DevOps is exactly, and like what is supposed to be the work of DevOps engineer. What is supposed to be the work of DevOps engineer? So so basically, a DevOps engineer is someone who uh, so a DevOps is someone who collaborates both with developers and operation teams. So a developer is sorry. Uh, so it development and operations team. So a developer sits somewhere around here. This is sorry, a DevOps sits somewhere around here. This is the place for DevOps. So it's understood that DevOps is something like a development in operations, or uh, a person or a DevOps engineer might be assumed to be a person who does development in operations, or someone who does both development and operations. Actually, it is both, and also not exactly both. So DevOps is someone who collaborates between a development team and an operation team, and ensures two features, and those two features are CI and CD. CI is continuous integration, and CD is continuous delivery. So a DevOps is a team. DevOps engineer is an engineer of a team which collaborates between uh, development and operations team, and their primary responsibility is to ensure CI and CD, where CI is continuous integration and delivery is continuous delivery. So when I say continuous integration, by continuous integration, I mean to say that the developers are able to collaborate properly, and they are able to push their code without any disruption or without any problems. And this is achieved by something like Git. So this allows different developers to push or publish their code using different commits, and like basically uh, the like with continuous integration, basically the problem is that there are different developers working on the same feature. So when there are different developers who are working on the same feature, they might uh, you know they might write some code which might conflict with the code some other person has written. So a continuous integration process is basically a process which ensures that all collaborators are able to publish their code independently, and there are not a lot of issues with pushing the code upstream. So how is it done? So continuous integration is done via writing a pipeline, or by writing a workflow. So Jenkins, or a workflow like GitHub workflow, or there is separate for GitLab. I don't remember the name exactly. So these can be basically used to ensure, like, whenever someone pushes a code. So when someone pushes a code, then there is a logic in Git to there's something called webhook. So basically a webhook is created so that whenever someone pushes a code, Jenkins is notified that this particular commit has been pushed. And whenever a commit is pushed, a Jenkins can create a job, basically, which can ensure that is this commit mergeable or not. So it can check if there are any conflicts or not, it can check if there are any test cases failing, like unit test cases or things like that. So what this job will ensure is that this job will ensure that the quality of the code, or whatever the developer has written, is up to the mark and can be merged with the upstream branch or the main branch. So that allows continuous integration. That is not in the scope of what we are you know talking about now. Next come continuous delivery. And continuous delivery is whatever is the latest software, that software is delivered to the customers. So how is continuous delivery ensured? So continuous delivery is ensured by uh, ensuring that whenever, again, it's the same logic. There is a webhook. Whenever someone pushes a commit to GitHub, the GitHub basically notifies Jenkins that this thing has come up, and then Jenkins basically runs a workflow. uh, like it can be any other workflow, not just Jenkins, but any other something like GitHub Actions or some other workflow engine can also be used for this. So continuous delivery, basically what it will do is that it will uh, again it might take care of the CI side also, and it does beyond what CI does. It pulls the latest code and deploys that code in the desired environment. Like uh, it depends upon use case. It might be possible that someone wants to deploy in dev, someone wants to deploy in QA, or any of the higher environments. So lowest is generally considered to be the dev environment, and all the environments like QA is supposed to be higher than dev, then UAT is supposed to be higher than QA, staging is supposed to be higher than UAT, and then pre-pod is supposed to be higher than staging, and prod is the highest environment. So generally we push the latest code to the lowermost environment, and then the code or the commit basically uh, climbs up the ladder of the environments and reaches the production environment. So if the entirety of this is automated uh, in such a way that a developer pushes a code, and that code is it runs through a CI pipeline, is merged, and then it goes through the CD pipeline and it deploy and is deployed at the topmost environment. That would be a perfect CI/CD automation. So that is what is desired. Now, since DevOps sit bit in the intersection of DevOps and operations team, DevOps need to ensure CI and CD, and Docker is very much relevant in this CI and CD space. So we'll see like where Docker fit into this, and like we'll go into a little more into the pipeline, what happens in the pipeline, and where does Docker fit into it, and what does Docker do. Uh, so yes, let's talk about that now. So we'll talk about the CI pipeline first. So what happens when like how does a CI pipeline get triggered? So it all starts with a developer pushing a commit. So when a developer pushes a commit, this commit reaches uh, the version control system. It can be Git, it can be GitHub, it can be some other version control system. Now, what does version control system do? It has a webhook, and that webhook informs Jenkins or some other workflow engine that this particular commit is the developer is trying to push this particular commit. So this goes to the workflow engine. Now, workflow engine, what it does is that uh, workflow engine runs some unit tests. What are unit tests? So unit tests are basically the tests that a developer writes, which when run, it covers the business use cases. So when let's say when I create a function like add two, I create a function to add two numbers. Uh, like let's say the function is add a comma b and return a plus b. So this is a simple function to return sum of two numbers. So we can write a test case for this, and the test case can be, hey, test that this function returns 5 when I pass 2 and 3 as arguments. uh, it can be parameterized, it can be multiple tests, like we can have multiple tests like ensure that when pass 2 and 3 the function returns 5, ensure that when I pass 5 and 0 the function returns 5. And it can also cover some uh, it can also cover some negative scenarios. Let's say you have written a function to divide two numbers, and on divide by 0 it raises some exception. You can write a test case that ensure that this exception is raised when I pass 0 as the second argument. So things like that, you can create some test cases, and these test cases can be run to see that the functions work in a you know desired way. So the first thing that happens after the code is after the workflow basically starts looking at the code is the workflow engine basically it pulls the code, and then the workflow engine runs some unit tests on the code. Then after unit tests there can be some functional tests. What are functional tests? So functional tests are basically so So unit tests are something that is inside the code. So it basically tests the code on a unit level, and the unit level can be a function or some class or a member method, something like that. That is a unit level testing, like testing that the value of this particular attribute is this, or testing if a function returns this when this argument is passed. So that something like that is called a unit test. And functional test is when uh, the functionality is tested. So when I say when a functionality is tested, it means that the software is tested for functional requirements from an outside viewpoint. So uh, it happens that the process or the software is run in a process, and some other process tries to interact with that software and tries to run the business use cases on that particular software and ensures that the results are correct. So this is what is functional test. uh, After functional tests, there can be some intake tests. So what can be intake tests? What are intake tests? So intake tests are basically those tests uh, which most of the applications nowadays are deployed in microservices architecture. So in microservices architecture, one service interacts with multiple services. So intake tests means that we deploy that particular service with the stable version of other services, and we look at how that service is interacting with other services. We run some tests around that, and these tests are called intake tests. So intake test or integration tests, they basically check if the service is able to integrate properly with the other services or not. Once the intake services pass, uh, also I forgot to mention, with unit test there can be some other isolated tests, like linting or linting tests or formatting tests. These can also be part of unit test, or it can be a separate uh, step which can happen before unit test. Um, yeah. So after intake test, uh, there can be some other tests. Uh, Also, one more thing I missed. I think there can also be some security scanning that can happen with unit test or as a step before unit test. And after intake tests have run fine, we can assume that the code is safe to merge, and we can allow the code to be merged. And how does it allows the code to be merged? It tells the version control system that the workflow is green. So when version control system knows that the workflow is green, version control system knows that this can be merged. So when developer pushes a commit or developer raises a PR or whatever, some based on some action of the developer, version control system notifies the workflow engine, and the workflow engine it basically pulls the code, checks the code, ensures that everything is in right shape, and if everything is in right shape, it allows it notifies the version control system that hey, the build is green, you can merge this. You can allow the user to merge this. It can be automatic merge, or it might require a user to merge it. So these are the steps. Now when workflow engine basically pulls the code, it has to pull the code. Workflow engine is also basically a software which is running on some particular server or some in which is running in some environment, some runtime environment. Now when it pulls the code, where does it pull the code? Does it pull the code in the same environment? If it pulls the code in the same environment, how does it run the code? How does it run unit test? How does it run linting and security scanning test, functional tests, and intake tests? So functional intake test, especially how does it run? Because for functional intake test, it needs to execute instructions not from within, but from the outside of the software. So how does it run function and intake tests? So uh, for all of this, these for all of these steps, um, this CI workflow makes use of Docker. So when it pulls code, it does not pull the code within the server itself where the workflow engine is running, but it pulls the code in a Docker container. When it runs unit test, it runs the unit test in that Docker container. When it runs the linting or security scanning test, it runs against the container in which the code lives. And it runs functional test. When it runs functional test, it spins the container, and it can, depending upon the requirement, it might have to spin up a database container if the software uses a database. It might have to spin up a Kafka container if the database, or if the application uses a, if the application uses Kafka service. It might have to spin up any other container that might be required in order to test the functionality of the software. And then for the intake test, it basically deploys that code in a container in one particular environment where the intake tests are run. So all of this CI pipeline makes use of uh, Docker in almost all the steps. Uh, so this is basically CI pipeline. There are sometimes there is also the CI pipeline also has a part where it builds the code. So if everything is green, CI pipeline also, most of the time, what it does is that it builds the code. When I say builds the code, so it's not like a Maven build, or like that can also be part, that can also be part of a CI pipeline. But when in most of the pipeline, practically nowadays, it builds a Docker image. We'll get to that later, how a Docker image is built. So basically, what it means is that it creates an image which from which a container can be spawned later on, which has the software of that particular commit running in it. So we'll get to that later. So this is like where this is like a simple CI pipeline, and I hope I was able to explain uh, that in almost all of the steps here in CI pipeline, Docker is employed. Uh, Now let's get to the CD pipeline. So I think it will be too much theory. I'll go a little faster. So in CD pipeline, it again starts with a developer pushes the code. Generally, it's not with a code push. It's generally with a merge. So when a merge happens on a version control system, and the version control system again notifies the workflow engine. It can be Jenkins or it can be GitHub workflows, anything. So this is the version control system, which in turn calls the workflow service, and then the workflow service basically starts the CD process. So continuous delivery. So what does it does for continuous delivery? So it does most of the things that is already, like, that is part of the CI pipeline. It runs the tests, it validates things. Um, Once it is done, what it does next is it builds the code. When I say builds the code, it basically, it for it might be that for Python code it builds and publishes a wheel, and for a Java code it makes a Maven. It might be a case like that. But in most practical scenarios, what it does is that it creates a Docker image. When it creates a Docker image, what it does next is that it pushes the Docker image to registry. Even I hope that you guys don't know about the registry also, so I will talk about it later. So registry is also one of the components of Docker. Generally, companies have their own registry where they keep Docker images, their own private registry, and yes, and that is where they push these Docker images. And when they have to deploy, they pull images from these Docker registry and deploy it in whichever environment they want to deploy it. So it pushes the image to the Docker registry, and then basically it deploys. And how does it deploy? It pulls from Docker repository and uh, runs it on this environment wherever it is supposed to deploy. So this is in context with Docker. If someone is not using Docker, then instead of creating an image, they will have to create a wheel or a Maven build. Like for Python, they'll have to create a wheel or a Maven build, and instead of pushing it to registry, wheel or build is pushed to artifactory, and then when it is supposed to deploy, it will pull from artifactory and deploy. But this is the old way of doing things, creating wheel and deploying, because uh, 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 there can be issues with that. So why there can be issues with that? Because uh, we might be building the wheel or the Maven on one particular this particular VM, and again it might introduce changes in the behavior of the software. Um Whereas if we whereas in containers, the behavior is usually maintained. So why, like, what, how does, like, so how does Docker ensure that the behavior is consistent? So we'll talk about that now. Once so when you write a code, like let's say there is some code that someone has written. Now when we want to run this code, what we need? So we need at least, so this code to run, how does a code run basically? So to run the code, we say, we ask the operating system, OS, hi operating system, run my code. This is my code. How do we say this? We say Python main.py, something like this, to run some Python code. Or for it's similar for other languages, we compile and then we run. When we run, we tell the terminal that we want to run this particular code. So this is how we say the operating system to run the code. What does operating system do next? So operating system basically, uh, it tells Python, hey Python, run this code. So you see this Python is the prefix here and main.py is the suffix. So what operating system will do? It will call the Python interpreter and it will pass main.py as an argument to the Python interpreter and say Python run this code. Now what Python will do? So Python again, it uses um, OS libraries to do what? To load, to create instructions from the code and load the code in memory. So it again, it uses OS only for this, OS libraries to load the code in memory, and then again it uses OS libraries to execute the instructions uh, from memory. So this is how this runs. And also, so basically it uses OS resources. Also it uses what else does it use? It also uses dependencies. Like let's say we have the software needs to talk to a database. In order to talk to the database, it needs the database driver. The database driver contains the logic to talk to the database, so it needs database driver as a dependency. In most of the programming languages, there are uh, different packages, like React is a package in JavaScript, in Node, Express.js is a package, Django is a package. There are a lot of many different packages out there. that sometimes a code might be dependent on. So there are some third party packages. So there can be a number of things like this that the code might be dependent on. So this is how a code runs in an environment. Now, when it's obvious when I run on another operating system, we have already discussed about that, that it might be possible that the code might behave differently. What happens in case of Docker? So when we run this, when we run in Docker, we package all of this together. So we put the code inside, we put the dependencies inside, we put the third party packages inside. So we put all of this inside a container. Whatever the code might need, uh, drivers, all kind of dependencies, we put all of that inside a container. And this is, and the output is this. This is created in the end. We create the entire container, and this entire container can be picked up from one place. It can be deployed in other place. So it can be like so basically it can be picked up and it can be deployed in any place. And when that is done, the dependencies and the third party packages, they will always remain the same, and that allows the code to behave in a same consistent behavior across wherever you run it, wherever we deploy the container from this particular Docker image. So why Docker and why not virtual machines? So I told earlier also that virtual machines almost already solved the problem why we had to use Docker. So that is mostly because of resource utilization, efficient resource utilization. So earlier what used to happen was there used to be uh, servers, different servers. Let's say these are my servers. This is my server A, this is my server B, this is my server C. So a company would have many servers to run different softwares before Docker and virtual machines was used to run one software. So this can be used, this might be used to run software one, this might be used to run software two, this might be used to run software three, something like this. So what happened when VM came, then it allowed us to have one server. So this is my one server, and we could create, you know, different virtual machines in these servers. And this virtual machine could then, you know, we can pull this A, B, and C, we can put it inside this. So we can put like uh, we can have this A here, similarly B and C. Containerization allowed us this. How did it allow? So it had the underlying uh, hardware, and it used something called a hypervisor. What does hypervisor do? So we'll talk about it. Hypervisor, I think, yeah. So let's briefly talk about, so hypervisor basically abstracts, not abstracts actually, what it does, it makes a pool, resource pool out of the hardware underneath, and it makes the pool available to the virtual machines, and the virtual machines can then, you know, pull in the CPU and RAM as per their requirement. So they can pull that particular requirement from the pool underneath the hypervisor, which is the infrastructure. So basically it allows the hardware, it allows hardware to support multiple operating systems. How does it allow? It allows by virtualizing the hardware in a resource pool, and then it allocates resources from the resource pool to the virtual machines. And these are the virtual machines VM. So this is my VMA, VMB, VMC. Now the problem with virtual machines is that the virtual machines has the application, it has the dependencies, but it also has a operating system layer. OS. So since a virtual machine has a OS, most of it resource pool goes towards the resource level work. Like resource level, basically the operating system is running, so operating system needs resources to run. There are many softwares, there are many processes that run in an operating system, and all of these processes need, in order to run, they consume the resources, which is hardware, which is RAM and CPU. And along with RAM and CPU, they also cause these VMs to have a boot up time which is higher than compared to Docker containers. What uh, what is different as compared to Docker container? A container is run on a host machine. So there is hardware, then we have operating system, and then we have a hypervisor, which is also like this type 2 hypervisor. In case of Docker, it's called Docker engine. So type 1 hypervisor is something that runs on bare metal. A type 2 hypervisor is something that runs on top of operating system and allows virtualization on top of operating systems. Docker is a type 2 hypervisor, and Docker engine is something which basically allows the containers to share the operating system. So the containers do not have the operating system layer, they share the same operating system layer, and that allows the container to only have uh, the app and the dependencies, and the containers need not have the operating system layer. Since the containers don't have the operating system layer, they consume far less RAM and far less CPU compared to virtual machines, and their boot up time is very fast. They come up very fast, they shut down very fast. You can work with them and it will work seamlessly, and that is because they do not have their own operating system, and multiple containers, they all share the same operating system. All containers share the same operating system. So this is how basically the Docker performs better than virtual machines, and makes everything lightweight, and makes everything fast. uh, so yeah, so what else? We'll quickly like we have had only theory till this time. We'll quickly go over some demo. Let me run something for you guys. So I have installed Docker Desktop on my VM, on my laptop. So this is Docker Desktop. So right now I have no container running. I have already pulled in a Python image. So this is Python 313 RC bookworm. Uh, so you can also check out different images here at Docker Hub. So Docker Hub is a Docker registry. I talked about it earlier. So when I say Docker registry, it's like a GitHub for code. Like we have GitHub for code. This is something similar for Docker images. So this is a place where uh, developers or DevOps engineers can collaborate. They can share images. They can push images to Docker Hub. They can pull images from Docker Hub. They can use it, and they can push their own images to Docker Hub for other DevOps engineers to use. This is Docker Hub. You can look for any image. Like for Python, if you want to look for an image, you can simply search Python. It will show you a bunch of images for Python. So this is one of the registry for Python. If I click on this, I'll see that this is the command to pull the image, and there are different tags. So I have pulled one of these. This is Python 313 RC bookworm. This is 313 RC bookworm. If I'm not wrong, bookworm is the latest Debian version. Other versions are like Bullseye is one old Debian version. Alpine is a different Debian distribution in itself. Um, there would be others, I think, even older versions. Slim is a Docker image which is a little more lightweight, and some of the packages have been removed from it in order to make it lightweight, which might be assumed to be used less. So if let's say there are some packages that people generally do not use a lot, they are removed and a slim image is made. So we have a this is my Docker container. Let me uh, also create a uh, uh, mkdir demo cd demo. So I have created a demo folder, and inside that demo folder I'm launching my IDE. So this is my IDE. So let me quickly talk about the components. There is only 1 minute left. I'll try to show something. So um yes, so the components are Docker engine that we already talked about. Then we have Docker registry, that is also something that we talked about. Other than that, we have Docker images and Docker containers. So images and containers can be uh, assumed to be like a class and an object. A class is like a image; it has a definition of how it is supposed to come up, and container is the actual thing, like object is the thing. When we create an object of a class. In the same way, we create a container from an image. And we have a way to create image. To create an image, we create a Docker file. So a name of a Docker file should be capital D Docker file. This is ideally what the name should be always, because this is what the Docker CLI would look for. If it is not Docker file, if it is not this name, then we have to explicitly define the name of the Docker file when we are trying to build the image for this particular Docker file. Let me create a terminal and let me create an image. So I'll see what images I have right now. So I have some of the images which have been pulled for Kubernetes, running Kubernetes clusters. And one of the images that I have that I can use right now is Python, Python image. So what I'll do is that I'll say from. So this from is a keyword to define the base of the image. So we are saying that we need to start with this image, which is the Python image, and this is my tag. So I'm saying from this I want to create an image, and the image I want to create, I want that image to run for infinite time, to not stop. So if I don't give this command, since there will be no command, the container will start and the container will exit also, because there is nothing to run. So I have asked the command to explicitly, I have added this command so that the container, when it is run, it sleeps and it does not stops and does not go away. So now that I have this in place, I'll build this. So I'll use this Docker file to build an image, and this is the command. The command is docker build, and then I need to say dot. Dot is to define the context. We'll talk about it later. And then we need to give a tag. What should be the tag of the new image that is going to be created? So I'll say make a tag like py and uh, py colon 1.0. So py becomes my image name and 1.0 becomes the version. And if I say docker build, so it will run this. It has built the image. Okay, Docker file cannot be empty. I've not saved this, sorry. So this has built the image. Now I can run this image. So I can say docker run uh, it docker exec it. I think for docker run I don't need to say it, and I need to give the name. So the name is py 1.0, and then I need to uh, say hyphen d. Hyphen d is to tell not to run in a attached mode, to run in a detached mode. So when I say attached mode, it will start outputting the logs in the terminal itself. I don't want that, so I have mentioned hyphen d. And then I need to give the name of the image, and the name of the image is py 1.0. And if I press enter, invalid container name, oh my bad, I have given the container name is wrong. I'll say test container. So this brings up my container. I can see what containers are running by using the command docker ps. So it shows me that there is one command which with the name test container, which is running with this command sleep infinity, and this is running. So what how we can go inside this container and we can look around. So we can run a Docker exec command. So this Docker exec command is to run something on the Docker container. So let's say I want to run Docker exec IT, and then the container, and then I'll say ls. So what it will do is that it will run ls command on the container, inside the container, and it will give us the output. So this is the output of ls command. So we can go inside the container, and in order to go inside the container, I need to run bash command. So bash is basically the terminal in Linux, and when I say run bash, so it will wait for me to give argument, and that will allow me that will basically open up and allow me to go inside the container and see. So now I'm inside the container. You can see the like this has changed its root, and it's supposed to be the host name of the VM, which is this container. And now if I run ls command, you can see the same output, and I can go inside different file, and we can see we can like do different things with this Docker image. It can run a different, it can run an application. We can do a port mapping. We can run database. We can do all of things with this Docker image. So right now I have this Docker image running in my host, and right now, no, even though no application is running on this Docker system, it can host an application, and it can interact with the like it can do a lot of different things that we will talk about later on. So yeah, that's it. uh, what else? So if you guys have any question, please drop in the chat. Like whatever I have covered, if you guys thought that something is if you guys have some problem with that, you can drop in the chat. There is some chat in here. Okay. Or maybe if there are no questions, then maybe Nathan can take over.